All right. You ready for this? You're ready for this. All right, so we're going to start this by looking at, if you were to look at the homework packets with this, you're going to kind of see it in sections. The first we're going to start with is repeating decimals. We're going to talk about how to write a fraction as a decimal. These are all things you should already know how to do. We're also going to look at summations and how we can write that as a series today. And we're also going to see if we can figure out what these series actually add up or approach, because they're going to approach a number. And so we want to figure out what they actually would add up to. So that's, I mean, it's literally a lot, but most of this is review. So how do you write 3/10 as a decimal? I said fraction, but decimal. 0.3. That's easy, right? This isn't supposed to be too much of a challenge. 0.3 or 3/10, right? What's the next one? 0.04, and the next one would be 0.7, right? Tenths, hundredths, thousandths. And what if I wanted 23 over 100? Good. And basically you recognize that that last digit is in the hundredths spot. Well, that's all well and good, because, I mean, let's be honest, it'd be nice if everything was divided by 100, because we could easily do this, but the truth is it's not. Now I want to take one in which you do know the answer to. You already know this decimal, right? Okay. How do I find out what that is without just, well, we know what 3/4 is, at least I hope we do. What's 3/4? 0.75. How do you find it if we don't know that decimal? Like, if you were like, I don't know what that is, I forgot. But so there is a way to do this using division. Remember that a fraction is another way of expressing division. 3 over 4. So we could write this as 3 divided by 4. All right, so this is the way that we would do it. This is like what you learned back in 3rd or 4th grade. All right, so does anybody remember? Because 4 can't go into 3, so what do we do with that? We put a decimal point and we put a 0. So because we haven't changed the value, it still means 3. And now we're going to do 4, instead of into 3, we're going to do 4 into 30, which is 7. Now we understand the 7, but we have to also carry that decimal up, right, to the top, so we understand that's 0.7. 7 times 4 would be 28. We would subtract. We get 2, and then what? Bring another 0 down. So even though it wasn't there to begin with, we can put as many zeros as we want. Drop another 0. 4 goes into 20 5 times. And you're like, oh my goodness, that's back in the archives, but hopefully we can do this. All right. So let's write as a repeating decimal. Remember this, that every fraction, every fraction can be written as a repeating decimal. Every fraction. No matter how many digits it takes, it is going to repeat. That's what makes it a rational number. Those are repeating decimals. And so something like 0.75, you're saying, well, that's not a repeating decimal. It is repeating. What's repeating in a decimal like 0.75? Zeros are repeating at the end, okay? So it can be zeros that we're talking about that are repeating, but every fraction has a repeating decimal. So how would we do then 7/9? Yep, and again, what that looks like is the 7 goes under and the 9 goes on the outside. We're dividing by the 9. And so just like we already talked about, we put that 0 down. So we really want to do 9 into 70. Can anyone tell me what that would be? 7, because that would give me 63. I'm brushing up on those multiplication facts. 70 minus 63 is 7. We bring down a 0. Yay. We get 70. 9 goes into 70 how many times? 7. So I multiply 7 times 9, I get 63, and I subtract, and I get 7. I bring down another 0, and how many times do you have to do this? Until you figure it out that that's what's repeating, and it's going to keep doing the same thing. So 7/9 is 0.7777777. So 0.7 repeating. All right, the bar over what's repeating. Okay, easy enough. Just as a quick little side note, does anybody know what 5/9 is? How about this? What's 3/9? 3/9 is also the same as 1/3, so that's 0.3 repeating, right? All right. What do you think 5/9 is? And how about 6/9? How about 8/9? Isn't this amazing? Nines are very cool. Nines are very cool. They have a lot of significant things. Isn't that just beautiful in there? There you go. It's 9-2 now. Right now. I just decided. That's great. 5-6. All right. So just quickly, everybody, why don't you go ahead and do this one on your own? 5-6. Okay. So we're going to look at how to convert repeating decimals to a fraction. And even though we've already talked about the pattern of what 0.7 repeating is, we still need to be able to do it for all kinds of decimals, right? And this is a series even though it doesn't look like one. Okay, so what we're going to do is I'm going to notice how many numbers are repeating. This is just the kind of generic way of teaching it. How many numbers are repeating in 0.7? One number. And so I am going to multiply by 10. If you think about the series, 7/10, 7/100, 7/1000, that's what's adding up here. Same idea. We're going to write it right over the top, 10s. And what that's saying is we're going to multiply s by 10. What's s? S is 0.7 repeating. Multiply this 0.777 by 10. That would become 7.7777 ... I'm writing it right over top. You'll see why in a minute. Everybody good so far? Now I'm going to subtract them. When you subtract 10s minus 1s, I get 9s. And when you subtract 7.7 repeating by 0.7 repeating, what you'll notice is the decimal bloop, 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 goes away. And what I'm left with is just 7. Now solve for s. Divide by 9. And so I get s equals 7/9, which you already knew from that pattern of nines. Isn't that cool? And the bottom line is you're trying to get rid of the decimal. So we multiply by 10 so that it moves the decimal over one spot. That's really what's happening. Okay, let's try another one. All right, we have s equals 5.3777. However many you need. With me, Jacob? Wonderful. Now, how many numbers are repeating? Only one number is repeating. 7, 7, 7, 7. Okay, so we're going to move the decimal over one spot. Okay? Is everybody with me? Okay, so 10s equals 53.7 repeating. And I just write as many as I need. I'm going to subtract 10 minus 1. Still 9. Yep, 9s. And I'm going to subtract. Notice the 7s, if you look from the right, are going to, because that's how you subtract, right? They're going to cancel. But I have 7 minus 3, so that's 4. I've got a decimal point. Carry that down. Back to the days of borrowing, right? Make that 13. That drops down to 4. 13 minus 5 is 8. I wasn't real confident out there, but okay, I'm going to take it anyway. Now what am I going to do? Yep, so we would divide. It is not real common, though, for you to see a fraction and a decimal, okay? So just to point this out, another way to remedy this situation is to simply do this. You can move this decimal point over one spot. You would just need to do the same to the bottom. And so another way of writing this would be 484 over 90. I just want you to be comfortable with that, because if you're in your choices for the CLEP exam, you see that, you would never see a decimal over in a fraction, a decimal and a fraction in the same problem. That's not what they would do. They would definitely make it so that it was not a decimal. Okay? It's just not good mathematical. Let's try another one. We haven't done with 2, so let's think about this. I want everybody on your paper to write s equals 0.47, okay? Good, Jaquise. She said you're going to write 100s. You absolutely are. You've got s equals 0.4747, da, 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 da. We're going to multiply. Why did you choose 100? It is. If you think about it also in terms of the subtraction, what we want is for these to line up. Okay, if you only multiply by 10, do you understand that they'd all be offset? You'd have 7 minus 4 and 4 minus 7 and 7, you'd be off. So by multiplying by 100, it basically allows for the 4s and the 7s to cancel out when I subtract, and leaves me with just the 47 there on the right. 100s minus 1s, 99s. And so s equals 47 over 99. Just like the same pattern with 0.5 repeating and 0.6 repeating being 6/9 and 5/9. Think about it this way. 47, 47, 47, 47, 47 is 47 over 99. Nines are really cool. So can you see that neat pattern? I didn't. We have a couple more things I want to look at. And we're going to start with when we have fractions written as a series. Again, the decimals don't look like they're a series because you're just used to seeing repeating decimals. But the truth is, that is, and if you look down here at the bottom, 7/10 plus 7/100 plus 7/1000 plus 7 over 10,000 plus da 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 would equal, and if you see it written as a decimal, oh, and combined would be 0.7 repeating. It's hard for us to recognize that what's really happening is you are, right, you are in fact dealing with a series when you're doing that S, quote unquote, method. Now, how do we deal with it? How do we do it when you have just a fraction? Okay? So here we have a series, and I'm going to label this as S still. Same kind of process, but what we multiply is going to be a little bit different. It's not as simple as just saying 10 or 100. Because decimals are on that base 10 system, right? That's what our decimals are written as. Tenths and hundredths, right? Base 10. So when we're dealing with a fraction, it's not limited to that. Let's think about what's the pattern that's going on between here. To go from 1/2 to 1/4, what do you have to do? You multiply by a half. And to get from 1/4 to 1/8, you see that the pattern is still the same. It should be, by the way. Okay? It should be the same pattern throughout. So whatever the pattern is between, that's what we're going to multiply S by when we're dealing with fractions. So instead, we're going to write 1/2 S. You're going to notice I put it underneath instead of on top, mainly because I have a choice and I want to keep it positive. Okay? And so I'm just going to put it under instead of on top. Now, when I multiply S by 1/2, let's think through this. 1/2 is the first term, but I'm multiplying that first term by 1/2. I get 1/4. What would be the next term? Yep, and then 1/16, da 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 da. And when we subtract, just like we were doing with those repeating decimals, when you subtract, again, let's look at the left, 1 minus a half, what is that? A half, so we have 1/2 S equals, what's left on the right? I hope you recognize that all the fractions are going to go away, except which term? The first term. So we did 1 minus the pattern here, and what's left on the right is just the first term. We're building towards something, a shortcut here. So start paying attention to this, because this practice actually will help you in the long run do a shortcut. To solve for S, what are we going to do? We're dividing technically by 1/2, but when we divide by a fraction, we keep change and flip. So I have 1/2 times 2 over 1, and I get 1. What this is saying is, if I'm to jump a half, and then the next time I only jump a quarter, and then the next time I jump an eighth, and I jump a 16th, do you follow that, thinking that what we're doing is we're eventually going to settle down on a number, or we're at least approaching a number? Okay, this is your first introduction to what we call a converging series. It's converging. It's kind of like the bouncing ball. If you were to take one of those cool bouncing balls and just slam that to the ground, it would bounce the first time really high. The next time, does it go higher? No, it goes about half. And then it goes half again, and half again, and you can kind of picture it in your own mind, can't you, where that ball eventually settles down. That's what's happening here, and we want to figure out what is it settling to. And so in this case, it's 1. Let's see another way of proof. about this, okay? Let's do it in the fraction form. So let's say S equals 7/10, 7/100, 7/1000, and on and on and on. The first question you have to ask is, what's the pattern between the fractions? What are you multiplying by in between? How do I get from 7/10 to 7/100? 1/10. Excellent. Following that? So what we're going to write underneath, what are we going to write? 1/10 S. And the first term that we would get when we multiply S by 1/10 is 7/100. And then 7/1000. In other words, as I pointed out before, the only thing that's going to be left on the right-hand side is that first term. On the left, we have 1 minus 1/10. How do I write 1 so that we can have a common denominator? 10 over 10. Shouldn't too much of a stretch, right? So what's 10 minus 1? 9/10 S. And we're going to divide, right? But we keep, change, and flip. And so what do we get? 7/9. My point is it's the same answer whether you do it in the form of a fraction or whether you do it in the form of a decimal. Are you with me? Okay. In looking at your homework packets, we already discussed, okay, we got some decimals, right? Most of those you can do even without doing this S thing. Okay? The next one gives you a fraction, and it says, okay, now I want you to write that as a repeating decimal. Okay? It's a doozy. It's a doozy. Number 3 talks about the fraction kind. And so what you have to do first is figure out the pattern in between those fractions in order to do those. But then you look at 3C and you slam on the brakes because you're like, holy Nelly, what was that just happened to be? So I want to do one just like you see in 3C and just one very, very similar to what you have there. Okay? So I want to do one with you and remind you about summations because, yes, summations are definitely on this CLEP exam and we can't be frightened by them. Remember, mathematicians are incredibly lazy. And what I mean by that is they don't like to write stuff down if they can avoid it. So what you have to do is you need to be able to write what this is. Okay? So we're going to start with the first term. What I mean by that is where k equals 1. Your first term is always when k equals 1. So I plug 1 in for k. What does that make that exponent now? 0. And anything to the 0 power is 1. So my first term is 1. Now this fancy little e here, sigma, represents what? What are we doing? It means we're doing a sequence, and what are we doing in between each term? You're adding. It's called a summation symbol, right? You're adding every term together. So when I finally do the second term, okay, I have 1 plus the second term. And so 2 minus 1 is 1, correct? So that would be 3/4 to the first power. The next term in the sequence would be 3 minus 1. And 3 minus 1 is 2. So this would be 3/4 squared. So that would be 9/16. The next one would be cubed, and the next one would be 4th, right? To the 4th power, and the next one would be to the 5th power, and on this series is going to go. So this, pardon this for a second, is S. So what's the process that we're going to do to figure out what is this approaching? Figure out your pattern. What are we multiplying by to get from 1 to 3/4? 3/4, right? And did we multiply by 3/4 again? Yes, it's true. So we're going to write 3/4 S equals, and I'd like you to finish that question. Are you good with that? All right.